In December 1995, the Galileo spacecraft approached Jupiter. It first flew past the ancient moon Callisto. Then its larger cousin, Ganymede. And the ice moon, Europa. All in all, Galileo made 11 merry orbits of Jupiter and its moons. Although the probe's high-gain antenna did not open, a less powerful secondary antenna will do its best to transmit some fantastic images back to Earth. On December 7th, 1995, Galileo fired a probe into Jupiter's atmosphere. Before it was crushed out of existence, that probe sent back new information about the Emperor of the Solar System. This is a time-lapse movie of Jupiter and its moons as photographed by one of the Voyager spacecrafts. You'll notice Io and Europa zipping through the picture. Jupiter's axis of rotation is offset from its magnetic pole. Its very high gravity is able to strip ions of sulfur from the surface of Io, creating a torus, or donut of ions surrounding the planet. Here, we're imaging Jupiter's huge magnetic field. The rings of Jupiter, invisible from Earth. Voyagers 1 and 2 gave us some magnificent close-ups of Jupiter's turbulent atmosphere, including the mysterious Great Red Spot, an anticyclone 4 times the size of Earth that has persisted for at least 200 years. Io transits across the face of Jupiter. The pull of Jupiter's gravity on Io's molten interior causes almost continuous volcanic activity. Io is always resurfacing itself. Here and there, you can spot a lava lake. The polar highlands are quite spectacular in and of themselves. The work of the computer and space artist combine to provide a sight never beheld by humans. Io eclipses the sun, as seen from its sister moon, Europa. Europa is covered by a frozen ocean. Some scientists believe liquid water may lie below the ice. Cracks in the ice are probably caused by compression. This is Jupiter's largest moon, Ganymede. Its most interesting feature is the unusual terraced terrain, which gives way to fields of craters. The outermost of Jupiter's large moons is Callisto. From Callisto's dark, aged surface, Jupiter and its satellites look like a miniature solar system. Our stop at Callisto ends with a view of its great impact basin, Valhalla. Glowing like a red ruby in Earth's skies, there was something almost fearsome about Mars. To the Romans and Greeks, it was the god of war. To others, it was the red eye of the devil himself. 19th century astronomers, like Percival Lowell, thought they saw lines that crisscrossed the surface of Mars. Italian astronomer Giovanni Schiaparelli actually drew maps of Martian canals and oases. This led to fanciful legends about an advanced civilization that had built the canals to irrigate its desert planet. In fact, billions of years ago, Mars once had an abundance of liquid water. But the thin atmosphere allowed it to evaporate, or perhaps it was absorbed. Mars clearly needed closer investigation. Earth-based telescopes couldn't provide the detail required for study. In 1976, 2 Viking spacecraft were sent to Mars to gather more information. On making orbit, the spacecraft were programmed to communicate with Earth. Ground controllers ordered the Vikings to deploy landers. Equipped with a heat shield, the landers would finally parachute to the surface before firing braking thrusters. This is Mars. Not the home of some fantastic civilization. A lonely desert, populated by rocks. Experience a Martian day. The night, colder than Antarctica. The noontime temperature seldom gets above freezing. Experiments were carried out to determine if life existed on the Martian surface or just beneath. The results were negative. Not surprising, really. In this frigid, arid desert, how could life gain a foothold? Especially with monster dust storms that ravage the entire planet. This is a computer-simulated flyover of Mars at over 200,000 miles an hour. The Valles Marineris below is a great canyon system that would stretch from New York to San Francisco. Mars has many features larger than those found on Earth. Here, we pass over the Tharsis Montes, giant volcanoes that dwarf Mount Everest. Olympus Mons to the northwest is over 80,000 feet tall. Perhaps someone alive today will be the first to climb it. This frost is actually frozen carbon dioxide and water ice. On Earth, carbon dioxide remains a gas. We exhale it whenever we breathe. This is Mars. Mercury is the nearest planet to the Sun. About 13 times each century, this small world appears to cross the face of the Sun as seen from Earth. These rare transits of Mercury should never be observed directly, or damage to the eye will result. The Sun is a seething cauldron of hot gas, mostly hydrogen. This solar flare is like a giant explosion in the Sun's atmosphere. Solar activity is ceaseless, as this time-lapse motion picture shows. A solar prominence which dwarfs the Earth in size and represents more energy than humans will use in 10,000 years. Mercury was formed from the solar nebula about 4.6 billion years ago. Its early history was marked by a violent cratering. This heavy bombardment caused molten lava to rise up from deep inside the planet and cover the surface. Another era of cratering and surface cracking gave Mercury its mottled appearance. The jagged terrain sits lifeless, with a glaring sun dominating the sky. Between 1973 and 1974, Mariner 10 made 3 flybys of Mercury, providing the best pictures ever obtained. Those photographs showed craters within craters within craters, a most inhospitable landscape. In addition, Mercury is continuously bathed by deadly cosmic rays. The possibility of life existing on this spare world is almost inconceivable. Although it looks a little like the Moon, there are major differences. Mercury lacks the great maria, or seas of rock, found on the Moon. Also, Mercury has a large iron core, which accounts for about 70% of its mass. One distinguishing feature, the Caloris Impact Basin, looks like a great bullseye, over 1,300 kilometers across. Mercury boasts the highest range of temperature in the solar system. On the Fahrenheit scale, its sunward side bakes at 700 degrees, hot enough to melt lead, while the dark side chills at more than 300 degrees below zero. The day is 59 Earth days long. Because Mercury has not been weathered by a thick atmosphere, it remains a pristine example of the early solar system. Perhaps we shall revisit Mercury in the 21st century. The edge of the known solar system lay Neptune and its great moon, Triton. Beyond it, the exploration of Pluto would have to wait for the next century. This graphic shows Voyager 2's trajectory for the Neptune encounter. On August 24th and 25th, 1989, Voyager 2 passed through the Neptune system. Before arriving at the planet, however, the spacecraft's cameras imaged the distant moon, Nereid, never more than a dot of light in the largest of Earth-bound telescopes. Here is the approach to Neptune, as recorded by Voyager's cameras. Neptune's rotation was measured to be 19.2 hours at the cloud tops, but only 16 hours 7 minutes in the deep interior of the planet. A faint system of rings surrounds Neptune. While in its turbulent atmosphere, winds were clocked at more than 1,000 kilometers per hour. Here are some real-time images of Neptune as received by the Deep Space Network. White clouds called scooters were observed for the first time. Neptune's most striking feature, the great dark spot, is seen here in an equatorial view. The great dark spot is actually a huge whirling tornado in Neptune's atmosphere. The dark spot is so large, the entire Earth could easily fit inside it. One last major photographic mission remained for Voyager. Neptune's largest moon, Triton, the coldest place in the solar system. Voyager discovered that Triton was somewhat smaller than expected, with a diameter of 2,705 kilometers. It also boasted a rarefied atmosphere of nitrogen with a trace of methane. A surface scan of Triton reveals a frozen world covered with cracks and the remains of ancient volcanic activity. As Voyager 2 left the solar system behind, never to return again, it became an ambassador of humanity to the universe. It is expected to pass by the star Sirius in another 358,000 years.
Pluto, celestial snowball, the Mount Everest of planetary exploration. It is the furthest, coldest, and hardest planet to reach. It is nothing like Earth or the other small terrestrial planets, and certainly not like Jupiter and its gas giant brethren. Because Pluto is so different, a mission to this tiny, frozen world may unlock further information on the origin of our solar system. NASA is hoping to launch 2 probes on a mission to Pluto and its moon by the turn of the century. After a journey of more than 7 years, the Pluto Express will fly within 3,000 kilometers of the ice world. In 1930, a 24-year-old student astronomer, Clyde Tombaugh, discovered Pluto while working at the Lowell Observatory. Many names were considered for Tombaugh's discovery. It took an 11-year-old girl, however, to suggest the name Pluto, the god of the underworld and brother of Neptune. How appropriate for such a forbidding planet. Pluto's moon, Charon, wasn't discovered until 1978. The planet and the moon are so close in size, with a ratio of 12:8, that they are sometimes considered a double planet. Together they orbit the Sun at such a great distance that our Sun appears merely as a bright star.
If the Saturn system can be described as complicated, then surely Uranus and its moons could be called unusual. Uranus is tipped on its side, its pole positioned about where the equator should be. Then, there's the system of Uranian moons. The orbits of the moons are also tipped, leading scientists to believe the giant planets sustained a titanic collision. Here was a gaseous planet with a featureless atmosphere lying on its side with its magnetic field offset from the rotation axis. What next? Next was Miranda, a moon which had apparently been blown apart, then reassembled by the force of gravity. Nothing they had ever seen prepared astronomers for Miranda's tortured landscape. Uranus, with its rings as dark as chimney soot, seemed to give off a soft blue light. Electroglow is a phenomenon of the Uranian atmosphere. Think of it, a planet and moon system apparently born of catastrophe. As Voyager 2 departed Uranus, scientists on Earth wondered if there were any surprises left. There were.
The brightest object in the night sky is the Roman goddess of love, evening and morning star, Venus.
As little as half a century ago, Venus was thought to be a twin of Earth. Being nearly equal in size, scientists wondered if it might be much like Earth, only warmer, perhaps even tropical. 1989. The Magellan spacecraft departs Earth. Venus is covered with an extremely dense, cloudy atmosphere. No human eye has ever seen the surface. Magellan carried with it equipment to see through the clouds and map the planet. Here are some actual time-lapse pictures of the cloud layer, which rotates around the planet every 6 days. Venus itself takes 243 Earth days to make a single rotation. Magellan fires its braking thrusters and enters into orbit around Venus. Using newly developed synthetic aperture radar, Magellan sent back mapping data, which high-speed computers have turned into a synthetic flyover. Our flight begins with a view of Sif Mons, a volcano 1.2 miles high. fly over a rift valley, several craters created by meteorite impacts. Gula Mons, another volcano, this one nearly 2 miles high. Our final view is of the northeastern side of the Isla Reggio Highlands. In 1978, Pioneer Venus visited with less sophisticated radar aboard. Pioneer Venus also carried instrument-laden probes to examine the Venusian atmosphere. The mothership releases sounders which will penetrate the atmosphere and then parachute to slow the landing speed. The atmosphere quickly becomes like a steamy soup. Droplets of sulfuric acid eat at the probe's skin. As the probe lands, it is being crushed by atmospheric pressure 90 times that of Earth. The atmosphere also creates colorful auras and rippling landscape effects. With a surface temperature of 900 degrees, Venus is the ultimate runaway greenhouse. This could have been the fate of the Earth had we been located a little closer to the Sun. Pioneer Venus discovered holes in the cloud cover near the poles. This time-lapse photography shows the changing shape and location of the holes, which are never visible from Earth. Ishtar Terra has an elevation equal to the Tibetan Plateau, but covers more area than the US. We have good reason to believe that Venus is covered with active volcanoes that help to spew lava and various corrosive chemicals into the atmosphere. On Venus, it rains sulfuric acid, which quickly turns to steam, a deadly inferno straight out of Dante. The Soviet probe Venera 9 actually survived long enough on the surface to take these pictures. Even as Magellan completes its highly successful mission, future probes are planned. In Venus, we have an example of a planet where something went wrong. Could the same thing happen to our home world?